Hey guys, welcome to this brand new Cinema 4D tutorial series on constraints. This series is mainly going to be focused on mechanical type rigging and how you can use the constraints inside of Cinema 4D to rig your mechanical objects. Also, as an added bonus, I'm also going to be showing you the differences between the native Cinema 4D constraints compared to Cactus Dan's plugin, which is CD constraints. So be sure to head over to the Insidium website to download the CD plugin. So you want to go to insidium.ltd/community/cdtools, and I will also put a link in the description to this download. And if you scroll down, you can download the entire plugin collection from Cactus Dan for free. Now, why is it free? Because back in the day, you had to pay for it. Well, you see, a few years ago, Dan passed away, and nobody really knew what was going to happen with his plugins. Fortunately for us, Insidium was able to get the code from his family and friends, and now they are offering it as a free download. So once you download the zip folder, you can extract it to your Cinema 4D plugins directory, and it will show up here in the plugins. So go to plugins, CD tools, and now we have all of the tools here, which is CD constraints, IK tools, joint skin, morph, PS tracks, symmetry, transfer, springy keys, and select parent. Now you don't necessarily need to have Cactus Dan's plugins installed in order to follow along with this series. However, seeing as how it's free, and I'm going to show you how to use it, and it's a great asset to have, then you might as well go ahead and download it and install it. Alright, so before we actually get started with any of the rigging, we need to talk about some basics. So the first thing that I want to talk about is rotation. Every object has three axes that it can rotate around. We have the y-axis, which is the green one, we have the x-axis, which is the red, and the z-axis, which is the blue. So if we were to select the object, we have three different rotational values, H, P, B. H would be heading, P would be pitch, and B would be banking. So if we were to adjust the heading value, you can see that we have a very nice stable rotation around the y-axis. And if we were to adjust the pitch value, we also have a stable rotation around the x-axis. And if we were to adjust the banking, we have a very nice stable rotation around the z-axis. Now the reason why all three of those rotations were stable is because the object's rotational values are all currently zeroed out. So what would happen if we oriented this object to a random arbitrary angle? So let's just rotate it up a little bit. You can see it's just pointing at a random angle. So now let's try to rotate those three axes again. So if we adjust the heading value, you can see that the rotation has now become unstable. It is no longer rotating around the y-axis. And if we adjust the pitch value, that rotation is also unstable. It is no longer rotating around the x-axis. However, if we were to adjust the banking value, you can see we have a stable rotation around the z-axis. And this holds true no matter how your object is oriented. So we could pull it around again if we wanted to. And the banking value will always be stable around the z-axis. This makes the z-axis the perfect targeting axis. This is why the camera looks down the z-axis. This is why the joint system points down the z-axis. This is why the targeting expression uses the z-axis, and also why the IK expression uses the z-axis when doing IK calculations. Okay, so now I want to talk about targets, up vectors, and the aim constraint. So what I've done is I've created two null objects and just made them visible in the viewport. One of them here is the target, and the other one up here would be the up vector. So if you remember, the z-axis is the targeting axis. So that leaves us with the two remaining axes to be used for the up vector. Now I can tell you that in my own experience, most of the time you're going to be using the y-axis for the up vector. Sometimes you may come across a situation where you just might need to use the x-axis for the up vector. But what I found is that in most cases you're going to be using the y-axis for the up vector. So let's apply an aim constraint to this object. There's several ways that you can do that. The first way is to right-click on the object, go to Character Tags, Constraint, and we need to enable Aim as well as Up. So in the Aim tab, we'll just drag in the target, and in the Up Vector tab, we'll drag in the Up Vector object. And now we can just animate the target, and there you go. So that's one way of doing it. Another way of doing it would be with the target tag. So we'll right click on the object, go to Cinema 4D tags, target, and this has the target and the up vector link box here for you. So you can just drag in your target and your up vector and you're ready to go. Now if you want to do this with Cactus Dan's tools, it's actually pretty easy to do it. So what you want to do is you want to select the object, shift select the target, shift select the up vector, and then call up the aim constraint command. Now you can do that by going up here to plugins, CD tools, CD constraints, and then you can click on add aim constraint. Or if you have yours docked in a palette like I do, you can just click on the aim constraint command and it will automatically add everything for you. And if we open up the target here, you can see that the target and the up vector, both of those were automatically added for us. And we can just animate our target and we're ready to go. Now I had tried to do this same method using the native Cinema 4D aim constraint, but it didn't work quite the same way. So let me show you what I mean. So if I were to select the object, shift select the target, shift select the up vector, and then go up to character, constraints, add aim constraint, you can see it added the aim constraint tag, but if we go into the aim tab, you can see that it added two targets for the Z axis. Now there is a little bit of a redraw problem here in the viewport, so I'm going to see if I can get it to update. All right, so there we go. All right, so you can see that we have two targets for the Z axis. And basically what's happening here is the Z axis is saying, wait a minute, you guys are throwing two targets at me. I cannot target both of these at the same time, so I'm going to go halfway between the two of them. So obviously this isn't going to work. So I'm using R18 here. Maybe some of you guys that are using R19 or perhaps R20, maybe you can give this method a try to see if it's been fixed. Now that I think about it, it's probably not really a bug. It's probably just something that can only be done with Cactus Dan's tools. So again, what you want to do is just, let me zero these out. What you want to do is select the object, shift select the target, shift select the up vector, and then apply the constraint. And then maybe you can comment below and let me know what happens. All right, so I'm going to go ahead and reapply the aim constraint here. So whenever you're dealing with targets, the target is always going to be absolute. And when I say absolute, what I mean is that the Z-axis is always going to be absolutely pointing at the target. So if I were to move the position of this target object, you can see that the Z-axis is absolutely always pointing at it. However, with the up vector, it is not absolute. It's more of just a general direction. So if I were to move the position of the target object, I want you to watch the Y-axis here to see what it does. Notice how no matter where I move the target, that Y-axis is always wanting to try its best to stay pointed in an upward direction. And it's even rotating around the Z-axis right there. It's kind of swiveling and rotating around the Z-axis to maintain its upward direction. The most common use for the aim constraint would be to animate the position of the target object, and then the constrained object will just follow it. But there's also another use for the aim constraint, and that would be to just leave the target object fixed in place and instead animate the position of the up vector. And when you do this, what we get is a stable rotation around the z-axis. And if you think about it, this would work very well for mechanical rigging because there are a lot of mechanical objects that have a fixed axle that they rotate around. And if you remember, I told you back at the beginning of this video that no matter which way your object is oriented, you'll always have a nice stable rotation around the z-axis. So if I were to select the target and move it up here somewhere, then we could take the up vector and move that around, and you can see we have a very nice rotation around the z-axis. So now let's take what we've learned about rotations, targets, up vectors, and the aim constraint, and let's apply it to something. So what I've done here is modeled up a very quick turret. It's made up of 3 objects. We've got the base, the housing, and the barrel. So before we start applying constraints to this and rigging it, we need to make sure that all of the axes for all 3 of these objects are oriented correctly. So when dealing with the base object, the base is going to be fixed. It's not going to be moving at all. So there's really no need to have to adjust anything here for the base. We can leave the axis the way it's oriented. Now for the housing, the axis for this is going to need to be changed. So we know that this housing is going to be rotating, and when it rotates, it's only going to be rotating around the heading value like so. That's the only movement that the housing is going to have. It's not going to be banking from side to side, and it's not going to be pitching up and down. It's only going to be spinning around one axis, and that's going to be for the heading. So the way that we want to set this up is that we want to use the base as the target for the housing. But if we do that, you'll notice that the target axis, which is the z-axis, is currently pointing backwards. So what we want to do is rotate this axis so that the z-axis is pointing down at the base. So I'm going to enable axis mode. I'm going to grab the rotate tool, and I'm just going to rotate this 90 degrees down. You can see now the z-axis is pointing down, but there's also another problem here. Now we're going to be using the y-axis for the up vector. And remember I told you before that if you leave the z-axis in place, or the target for the z-axis is fixed, in this case it's going to be the base, then we can just animate the up vector object. But the problem here is that the up vector for y is pointing backward, and we just want to spin it around so that it's facing forward. So I'm going to rotate that 180 degrees. And now our axis for that is set up correctly. So now we need to set up a controller. In this case, the controller is going to be the up vector. So I'm going to create a null object, and I'm going to change it to something visible that we can see. I'm going to use a sphere. And I'm going to change the color to just maybe a bright blue color. And we'll move that out in front up here. That's going to be our controller. And now we can apply the aim constraint. So I'm going to select the housing. I'm going to shift select the target. Now remember, in this case, the target is not a null object. The target is the base. And then I'm going to shift select the up vector, in this case the controller. And then I'm going to apply the aim constraint. So now if I take the null object, which I should rename that to controller, and now I can move this around, and you can see that the housing rotates with it. This also works the same way with the native Cinema 4D aim constraint. So I will quickly show you that. So we'll right click on the housing and go to character tags, constraint, and we want to enable up. And you can see as soon as I did that, it kind of flipped and rotated. So what I want to do is drag the base object into there. All right, so now we want to go back to the tag and we want to go to up. And for some reason, it's going to flip on us. And I'm not sure why it's flipping. But if we drag in the controller object into the target, now the whole thing has suddenly flipped on us. I'm not sure what's going on there. It could just be a redraw issue. So let's try that. Let's try redraw. That didn't work. That's not working. So let's grab the controller and move that. Okay. So I'm not sure what's going on there. That could be a bug. Maybe you guys are experiencing the same thing. Let me know down in the comments if you also encountered the same problem. It appears to be some type of a redraw issue maybe. But now we can just move this. We move the up vector controller and it's working. So I'm just going to undo this a couple times to go back to the CD aim constraint. All right, so now we need to work on the barrel. All right, so we need to adjust the axis on the barrel because if we click on the barrel and go to a side view, there are two issues that quickly stand out. The first one is the pivot point or the rotation point, because right now the rotation point is wherever the axis is at. So if this gun barrel were to pitch and move around, it's going to be moving right there, and I don't really like that. I would rather have the movement or the rotation be further down inside of the housing. So what I'm going to do is I'm going to enable the axis mode, and I'm just going to push the axis a little further down. I think right about there will be okay. Now the second problem is that the Z-axis is pointed up, and it actually needs to be pointing down the barrel. So we need to rotate that around, but we also need to be mindful of the up vector that we're going to be using, which is the Y-axis, and that needs to be pointed up. So what we'll do is we'll grab the rotate tool, and we can just rotate this around 180 degrees. And now we can just rotate it 90 degrees this way. And that should take care of it. So now we have the Y-axis for the up vector pointing up, and the Z-axis for targeting is pointing down the barrel. All right, so now we can set up the up vector and the aim constraint for the barrel. So what we could do is use the add root null in the CDIK tools. And what that does is it places a null object at the axis point of the object that you have selected. So if you don't have yours docked in a palette, you can just make sure your object is selected and go to Plugins, CD Tools, CDIK, and then we want to click on Add Root Null. What that does is it places a null object at the axis point of the object that you had selected. So I'm going to take that root null and just push it up in the Y-axis. That's going to be the up vector. So we can actually rename this to barrel up vector. And we know that the up vector object that we're using as the controller for the housing, that can be used for the target for the barrel. So we'll select the barrel, shift select the target. In this case, it's the up vector controller. And then we will shift select the up vector and call up the command for the aim constraint. So now if we just animate the position, okay, so notice we've got some intersecting going on right here, and that does not look correct. So the problem with this is that we need to make the barrel a child of the housing, because remember, the barrel is going to be moving with the housing. So we need to take the barrel and drop it as a child of the housing. And now when we animate the controller, now it's working properly. So now the barrel is tracking absolutely with the target, and the barrel and housing are rotating around the fixed base. All right, so I think I'm going to go ahead and wrap up part 1 of this series. If you have any comments or questions, feel free to comment below. And in the next part, we're going to continue talking about the aim constraint, more specifically double targeting. So as always, thank you guys for watching, and I will see you in the next tutorial.